All right, welcome everybody to week 3, day 3. We're going to be talking about some important things today. We're going to be learning how to do a nested for loop, a loop inside of a loop. We're going to be continuing to work with strings inside of loops and how to access characters with a string inside of a loop. Last time we learned it kind of the slow and hard way. Today we're going to learn an easier and faster way, faster to type, not necessarily to run, way of messing with characters inside of a string. We're going to continue our exploration of CC type, which gives you all sorts of cool little functions to do things like uppercase a letter, to tell you if a letter is uppercase, to tell you if a character is a number or a letter or a space or something like that. So let's get going. And let's start off with just some CC type stuff. So if I have string s is equal to read, read is not standard C++, it's just a thing on our server, so don't get too comfortable with it. You're not going to find it on anywhere else, really, unless they've downloaded it off my GitHub. So please enter your name. So last time we did a for loop that looks like this. For int I equals 0, I is less than s dot size, I plus plus. And so this is like saying, if I had to read this in plain English, for every index from 0 to the end of the string, cout s dot at that index followed by a new line. Print the character at that index in this string with a new line. Okay, so if I were to compile this and run it, you'll see that it prints it vertically. Okay, so you should probably ask, it's been saying you have new mail. Yeah, so every time I grade the homework, it will send you an email. So if you were to type Alpine, it will launch the mail client. The first time you launch a mail client, it prints this greeting. You hit E to exit it. You go up to I, hit return, and it will show you your grades. I'm obviously not going to show it on YouTube, but it'll tell you what grade you got on the most recent homework assignment. You can also check it on Canvas. I've already put the simple calculator grades up on Calculus, but that's what that's telling you. Okay, so let me show you. This is one way we can do this. This is option 1. And this is the kind of old school way. There is a new way, option 2, which is the C++11 and newer way, which is called the range-based for loop. Sometimes called a for each loop. And so what we want to say is, for each character in the string, print that character followed by a new line. And it looks like this. For char C in S, so for every character we call C in S, in this string S, cout that character followed by a new line. So these two loops are exactly the same. This one has a little bit more typing involved, and so I would probably prefer this one here, all right? And so you might notice some important differences, though. For one thing, here, it's really talking about the index of the characters in the loop. So it starts at index 0, and it goes to the last index in the string. And then it's printing out the character at that index. Here you can see there are no indices whatsoever. And so when you do things this way, there's always the possibility you screw up, right? Like you might have a out of bounds error if you did something like this, right? If you did something like that, then you will explode like that. You went out of bounds. No, you're out of bounds. No, you're out of bounds. The nice thing about the range-based for loop is that it can't. So if I were to run this code and type in Bill, you will see it prints Bill vertically, and then the other loop prints Bill vertically. It is exactly the same code. So, like, look, there's no I anywhere in here. There's no index. There's no size. There's no s.at. It's actually just much easier to work with. It's limited to just when you're looping over an entire container. Like in this case, a string is a container of characters, and you just start at the beginning and you go to the end. There's no, with this for loop, you can do things like say, hey, just print the first half of it, right? If you did something like this, it would print the first half of the string, right? You can't do that with a range-based for loop. It's just you start at the beginning, you go to the end, kind of thing. Which is what you do most of the time, but not always. So you still need to know the old school way first. For each loop is really nice. It's very clean. It's really easy to read. Modern C++ only, though. If you transfer to a school that doesn't allow you to use modern C++, tell them it's been 11 years. It's time. It's time. It's been a while. Technology moves fast, and it's been 11 years. We've had 3 standards come out since this one. And there's a new standard for C++ coming out next year. It's time to at least advance to C++ 11. Okay. So, what if I wanted to print all of the characters uppercased? Well, I could do this, but you're going to encounter one of the weirdest bugs in C++. And that is... And that is the fact that toUpper doesn't actually return a character. toUpper bug alert. toUpper returns an int, not a character. This is an artifact of the old days in which characters were integers. And so if I type in Bill here, you will see this thing here is printing Bill, but these are the ASCII codes. So 66 is the ASCII code for B. ASCII is the standard way of converting letters to numbers. So you can see here, B is in fact 66 in decimal. And then I is 105 and things like that. So 73. Oh, it's capitalized, right? So capital I is 73. L is 76. So capital I, capital L, capital L. Okay. So how are you going to teach a tech-based major if you won't use the latest software? That's a great question. But there's good things and there's bad things about being tenured. The good thing is like administration can't lean on you, one way or another. You can just basically tell them to go pound sand. I'm going to teach the way that I want. The trouble is if the way that the professor wants to teach is based out of the 1970s, you as a student have very little leverage in the matter, right? Tenure is one of those things. I, in general, support it. I think that, hang on, my old instructor is calling me again. Hang on. Okay, so if you want this to work properly, you need to do something like this. C is equal to toUpper C, and that will store it into a char, and then when you print it, it will work properly. So here we go. Bill, all capitalized. Now what if I wanted to lowercase a letter? Do you remember how to do that? If toUpper uppercase is a letter, anyone want to place any bets, any memories from Wednesday on how to lowercase a letter? Yep. So if I type in the first for loop, I'm going to delete that first for loop out, but you can see, here we go, it's all lowercase. And I'll get rid of the end line here. At the end here. Okay. Now, there's also code that's like is lower. Okay. So this function here tells you, oh yeah, you can't put a slash in the name. So Garcia, you're trying to save a file named 8/26. You can't do that. So hit :W and then type in like foo.cc or something like that doesn't have a slash in it, and it'll save it to that file. So what does char CS mean? It means this exactly right here. So for every character C in the string S, do this code. So let's say that our sample code is like hello, or the string we typed in is hello. The first time through the loop, character C, it's a variable, character C. The first time through the loop, character C is going to be set to be the first character in S, which is H. So the first time through the loop, character C is going to be H, capital H. Next time through the loop, character C is going to be set to be E. Next time through the loop, C is going to be set to L. Next time through the loop, the second L. And the last time through the loop, character C will be set to be lowercase o, and then the loop ends. Okay, so it creates a variable named C of type char, and it's going to be set in turn to each one of the letters in the string. So it's saying for each letter C in the string S, do something with it. In this case, we're saying if it's a lowercase letter, print it out. If it's not a lowercase letter, do nothing. So if I were to type hello, it prints hello. Hello, love. Right? Because H is a capital letter. So when you say is lower on capital H, it's like, no, it's false. So it doesn't print the letter. But lowercase e, lowercase l, and lowercase o is lower is true, and then it prints out the letter. Okay. So what if we wanted to do the Mocking Spongebob? You guys familiar with that? So we've got, inside of CC type, we've got a couple different functions that are kind of useful. CC type, key functions. You have to know. R is upper, is lower, to upper, to lower, is alpha, is num? It's not an is though. What is it? Is graph, is space. Is space tells you if it's a space or a tab or something like that. What is it? Is num. CC type is num. Number? What is it? Is digit, right? Is that it? Pull up. Is digit, yeah. So is digit. This is the other huge one. Yep. So I would like for you to write code that will do Mocking Spongebob. Okay. And maybe what is alpha? So if it's a letter. So for example, if I wrote is alpha, that'll be true if it's a letter. And if is digit, let's see, we'll see out. See out a cat. Okay, so for any letter in the name, we print out the letter. If there's any numbers in the name, we print out a emoji cat crying instead. If it's anything else, it doesn't get printed at all. Okay. So run this. If I type in hello, we get hello back. If I type in hello with sevens, we get the sevens get replaced with cats, right? Because those are digits. If I type in hello with an exclamation mark or 10, the exclamation marks don't appear because they're neither a letter nor a number, so they don't get printed at all. Okay. So all sorts of useful stuff in there. To upper, uppercaseifies it. To lower, lowercaseifies it. Is upper tells you if it's uppercase. Is lower tells you if it's lowercase. Is alpha tells you if it's a letter, capital A or lowercase, either way. Is digit tells you if it's a number. Okay? And then there's other things. Is space. Is graph. This gives you if it's a space or a tab or a new line. Graph is like basically any printable character, not control codes, things like that. Okay. There's is alnum. Alnum is either alpha or a digit. Okay, so in order to do Mocking Spongebob, which is always fun, let me make sure you guys are aware of the meme Mocking Spongebob meme. It is a meme in which you sort of randomly uppercase. You can't just put that meme on everything, right? Basically, you just randomly uppercase and lowercase things, right? And so we could do that with what we know right here. There's just one more thing we have to do, which is figure out how to do random numbers. Okay. That's perfect. Okay, so basically we're going to do this. The user is going to type in a sentence, tuition and books are expensive, and then you're going to write back sort of randomly capitalizing, 50-50 chance of capitalizing each letter. That's kind of what our lab time is for today. Before we do all that, though, we need to have a lecture on random numbers. Okay. So, so there are two parts to doing a random number. The first is to seed. Two parts to doing a random number. Part one, the first line in main and basically nowhere ever else you call srand. Srand initializes the random number generator to produce a very non-random series of numbers. Okay, so if you were to do the following, let me just comment out this code down here below. We'll come back to it in a little bit. So if I were to call srand passing in a seed of like 100, this picks random number sequence 100. So we will get the same sequence of random numbers out of rand every time we run this program. So that's step one. You have to pick what sequence of random numbers you want to get. It's not random at all, actually. You just pick which random numbers you want to get. And then the second thing is you call rand. And it will give you a random, double quotes around it, number next in the sequence. Okay, so if we were to see out rand a bunch of times, then we get some random numbers. The numbers range from 0 to at least 32,000 in modern implementations. They range from about 0 to 2 billion. Okay? And if I run this again, watch me get more random numbers. And if I run it again, we get more random numbers. They're very random, aren't they? How are the numbers generated? Who knows? Doesn't matter. There's a whole bunch of different algorithms to do what are called PRNGs, pseudo-random random number generators. The actual implementation detail doesn't matter. All that matters is that you get the same set of numbers every time you run the code with the same seed. So if I were to reseed it, like in the middle here, right? So when you call srand, it initializes the random number generator to produce the exact same sequence of numbers. So any guesses on what you're going to see for these three? When I reseed it, which you're not supposed to do, by the way. Voila. You see that? I got the same three numbers. So srand picks which sequence of numbers you're going to get. And then when you call rand, you just get the next numbers in that sequence. It's deterministic, not random in the slightest. Okay? You see that? So we call srand, and then it just says, all right, pick random number sequence 100. And then it just gives you the next numbers in the sequence every time you call rand. And if you call srand again, it resets back to the start, and you get the same three numbers every time. And this is actually very useful. If you've ever played a video game like Terraria or Minecraft or Civilization, where it asks you to input a random number seed, what that allows you to do is like share it with your friends. You're like, oh, I got this really cool random map generated. They're like, oh, what's your seed? You say, oh, it's 774422, whatever. And then when they create their world, it asks them for the seed, and you give them that, and they end up randomly generating the exact same world that you have. And they're like, oh, wow, yeah, look at this. There's all these waterfalls and stuff, stuff like that. You generate the same world with the same seed, exactly. And so what you can do is sometimes we can do this, like see out, please enter your seed, and seed. Make sure you don't not initialize your variables. I saw a lot of people last night not having initialized variables. Seed. And then, if I run it with seed 100, look, it's the same numbers I got last time. But if I do seed 200, then they're completely different. And seed 1 and seed 2, seed 3, each one of these is a completely different sequence of numbers. And if I pick seed 3 again, you'll notice I get the same sequence of numbers every time. If I pick seed 2 again, I will get these same numbers here, right? 1505, 1505. Yep. So what seeding random number generator means is it's just picking which sequence of numbers are going to come out of that random number generator. Okay. So they're not random at all. It's not random. Okay. Has anyone here ever played a video game called Final Fantasy 12? It's a bit old. It's right on the cusp of the PS3, PS4, I think. Or was it PS2? No, I think it was PS2. I think it was like the last game for the PS2. Yeah. That came out 16 years ago. And so, not a bad game, honestly. Zodiac. And then they retweaked it. So the way that it worked in the original version, basically there were certain chests that if you hit them, they had a 1 out of 100 chance of giving you the Zodiac Spear, which is one of the strongest weapons of the game. And it was actually available right towards the beginning of the game. Let's see if they have the thing here. Yeah, 1% chance to spawn. Okay. And these people are saying, oh, just walk in and out until you get lucky. No. Here's the thing about Final Fantasy 12. They don't call any random number generation in the game. What they have is they have one sequence of dice rolls. And when the game starts up, it randomly picks a spot in that sequence of dice rolls and it just goes through them. And so, if you want to get that lucky 1 out of 100 chance of getting the chest, what you do is you walk into a combat and you hit monsters. And you just look at the numbers coming out when you're hitting monsters, and you look for certain numbers appearing. 45, 21, 22, 60. That's it. That's the sequence right before the 1. And then you run away from combat. You avoid combat with all monsters because you know the next number that's going to be rolled is a 1. You walk up to that 1 chest, you open it, and you get the Zodiac Spear. Because it's not random whatsoever. So people just go into combat and they just look at the numbers coming out, like, oh, that's random in the sequence. And then stop, and then run away. And then you have to dodge every combat. You can't open any chest. And you get to the right spot, you open it, you get the ultimate weapon very early in the game. And that's because it's not random in the slightest. Okay? It's a really funny bug. I tried doing it myself and I got bored out of my mind because you have to sit there and hit monsters and just like pay attention, like every number coming out. And if you miss it, like you hit one more time or they hit you one more time, it's like, oh Lord, yeah. I tried doing it. It was just too tedious for me. I'm sorry. I did the Final Fantasy VII lightning dodging thing, and that was like it for me for Final Fantasy. Stupid grinds like that. I don't know if you guys know what I'm talking about. It's one of the dumbest mini games ever. So you have to go into this area of the map, and then lightning will flash, and you have to hit jump right when the lightning hits you. And do that over and over and over again. Perfectly doing it 200 times in a row. I did that. That was it for me. That was the end of me putting up with Final Fantasy's stupid, grindy mini games. There you go. Yeah, imagine getting a duel and then they suddenly get excited and run away. Yeah, it's really funny. All right, so how do we make these things into like normal numbers? Okay, so rand returns a number from like 0 to 2 billion. Okay. So how do we turn this into like a coin flip? How do we turn this into like a 6-sided die? How do we turn it into a 10-sided die? Well, the most common way of doing this is using modulus. Okay. So if we modulus it by 6, that means you're dividing the number by 6 and keeping the remainder. So if you divide a number by 6, what could the remainder be? What range of values could the remainder have? Like 10 divided by 6 is 4, right? 12 divided by 6 has a remainder of 0. 13 divided by 6 has a remainder of 1, right? So 13 modulus 6 has a value of 1. 14 modulus 6 is a value of 2. 15 modulus 6 is a value of 3. 0 to 5. Yeah, so if you're trying to roll a 6-sided die, and most 6-sided dies are 1 to 6, we take 0 to 5 like this, and we add 1 to it. So this is going to give us a 6-sided die roll, and if we're playing Yahtzee or something like that, we get 1, 2, 5, 4. Do we have 1 too many? 2, 3, 4, 5, 6. Is there 7 there? Oh, because 1's the seed. Okay. Yeah, so it gave us 6 dice rolls, 2, 5, 4, 2, 6, 2. So we got 3 2s. Not bad. It's a good starting hand for Yahtzee. Okay. Now if I choose a seed of 1 again, oh look, I got the exact same dice rolls, right? It's not random, right? If I pick a seed of 2, then we go 1, 2, 3, 6, 4, 1. It's 1, 2, 3, 4, and 6. We're very close to a long straight in Yahtzee. Seed of 3. Yeah, we got 3 1s. That's a really good Farkle hand there. Do you guys understand? So basically, rand modulus 6 will give you a number from 0 to 5. So we add 1 to that, and that gives us the numbers from 1 to 6. If we wanted to do a 10-sided die or 20-sided die, like let's say we're doing D&D, right? Then 20. So if you modulus something by 20, it'll give you a value from 0 to 19. You add 1 to it, that gives you the values of 1 to 20. So YY 5T. And let's do some D20 rolls, okay? So we got 4, 7, 18, 16, 14, 16. Not bad. Not bad at all. All right. Seed of 2. Ooh, we got a nat 20 there. Still no nat 1s. Oh, there's 2 nat 1s on this one. That's not good. Got 2 natural 1s. Not a good roll at all. Okay. So any questions about this? So how do we do a coin flip? So if this is how we do dice rolls, what do we do to do a coin flip? rand modulus what? So we in the previous class said rand modulus 1. But modulus 1 will always give you 0, so it's not very useful. If you do modulus 3, there's 3 possible outcomes for the coin flip. 0, 1, and 2. Right? So maybe, Alessandra, you were thinking like the coin landing on its side or something like that. Rand modulus 2 plus 1. I probably wouldn't actually put in the plus 1 there, because usually when we do coin flips, we're actually kind of thinking about like true or false, right? Because for the SpongeBob meme, what we're going to do is like say if the coin flip is true, then uppercaseify it. If the coin flip is false, we're going to lowercaseify it. Okay, that's what you're going to be doing for lap time. And so in that case, we don't want to add plus 1 to it because remember, 0 is false and everything not 0 is true. So 1 is true, 0 is false. Okay. So if we want to do some random coin flips here, get some trues, got some falses, right? So we're kind of randomly getting some trues, some falses here based on the seed. So what if you want to not have to enter the seed every time, right? What if you just want it to be sort of like random? Well, a very common approach people take is they seed the random number generator with the time. So there's a function called time, and it's the number of seconds since time began. And so this works okay. There's 2 big problems with doing this. One, if you run the program twice really quickly, you get the same coin flips. You see that? Because it's within the same second, right? But if you kind of run it more slowly, you notice, oh look, I got like a bunch of heads. If you wait a little bit, you get random numbers. Almost all tails in that one. Right, so this is a very common way that people do it. But it's not great because if you run the program twice very quickly, you'll get the same outcomes. And the other downside to it is that it's still predictable. If you're making an online poker game, then you really don't want to use the current time as the seed for the shuffler. Because what I'm going to do is I'm going to seed a shuffler on my phone or computer, and I'm going to shuffle the deck the exact same way that you're shuffling your deck. I'm going to deal out the cards, and I'm going to see if the cards that I get are the cards that are in the video poker game. I'm like, oh ho ho, I know what numbers are coming next, right? And so I know exactly what cards are in the deck. I know exactly what cards are held by all the people in the game, and I win, right? It's very hard to lose at poker when you know the cards that everybody holds and what cards are in the deck. It is possible, like they could just be dealt a pair of aces or whatever, in which case you fold or whatever, but you basically would win at any online gambling game. You know, you're playing online roulette. You know what number is going to be rolled next. You know, I'm going to bet all $1 million on 50. You know, so yeah, you want it to be 0, 1 so that it's true and false, right? Because you can do something like that, right? Like you can do you do something like this, right? So you flip a coin, and half the time it'll say Taylor Swift is the best musician of all time. Half the time it'll say Justin Bieber is the best musician of all time. So if we compile this and run this, you'll see Justin Bieber's the best, Taylor Swift's the best, Justin Bieber's the best, Taylor Swift's the best, Justin Bieber's the best. Wow, this is actually perfectly coin flipped. There we go. We got 2 Justin Biebers in a row. Taylor Swift, Justin Bieber, Taylor Swift, Taylor Swift, Taylor Swift, Taylor Swift. Okay. So yeah, you don't want to use rand modulus 2 plus 1. If you did rand modulus 2 plus 1 here, then it's always going to be Taylor Swift, right? Do you see that? Because this is going to always be true, right? 0 is false. Everything not 0 is true. Okay. What do you guys think? Do you think that given what you know, using is upper, is lower, 2 upper, 2 lower, that you'd be able to go through the, type in the name, and you're going to turn like hello into like HELLO, something like that, right? So your lab time assignment. Oh, that's also something I want to mention to you guys. Like, let's say I'm here and I want to edit the line above it. Shift O. Shift O opens the line above. If I'm here and I want to open the line below it, lowercase o. Okay. A lot of students have to do this. Like, with what they know, they type I to go into insert mode, and they go return. Don't do that. If you're just in the middle of a line somewhere, Shift O opens the line above, and you can start typing immediately. Lowercase o opens the line below, and you type immediately. This is most important when you're working on if statements and for loops and things like that. So many students I saw in lab time today were doing something like this, like for and I equals 0, I is less than 10, I plus plus, open brace, and then they just start writing code. And then by the time they're like down here, like they've forgotten that they need a close brace. Okay? This is why most modern text editors will actually insert a close brace for you automatically. Vim doesn't. You can actually, I posted on Discord how you can make Vim act that way. I actually don't like it because whenever an IDE inserts a close brace for me, it half the time is in the place where I want it. And my workflow is such that I don't need it to do it for me. Like, it doesn't, it literally just gets in my way. But here's how I recommend doing it. So you do a for loop or something, open curly brace, return, close curly brace, escape. And now I want you, so you make the buns of the hamburger first, then you do the inner part of the hamburger. Okay. Now, a lot of students would do this, right? They would go insert mode, one more right arrow, return. No, don't do that. Instead, after you type the close curly brace, Shift O, and there you go. You're now able to immediately type inside of there. Or if you're here inside the for loop somewhere, lowercase o, and there you go. So this is a Vim pro tip. Vim tip, O opens the line below, big O opens the line above. Okay, very useful stuff. Mincorelli also wanted to mention the scoping rules. So if I make a variable inside of a for loop here, and if I make int Bob is equal to 42, I can see out Bob here. So this is going to print 42 10 times, right? But if I tried c-outing Bob here, this code will not work. And the reason for that is because Bob does not exist anymore. So C++ has the note, yes, Shift O is a game changer, it really is. So C++'s rule for variables is that they live within their curly braces, okay? So Bob is surrounded by an open curly brace here and a closed curly brace here. That is called Bob's scope, like the mouthwash, right? Bob's scope is this for loop. Bob does not exist here. Do you guys understand? Bob only exists within that for loop. So if you want something to persist outside of the for loop, you would have to do something like this, right? And then it would be fine. Now I could make another Bob down here, and that's fine also. But this Bob, completely different guy named Bob. Okay. This Bob here is a variable, no relation, same name, no relation to that Bob. They're just two different variables named Bob. They're in different scopes. It's okay. Now, if you wanted to do this, this won't work. Why? Because now you've got two Bobs in the same scope. And this is violating the ODR, the one definition rule. In C++, you can have one definition for something, period, and we are violating it. We've got Bob here, we've got Bob here, and we are not allowed to do that. We can't make Bob twice. But if they're in different scopes, it's okay. What do we use instead of srand time 0? Nothing. That's... So you're asking what's more proper? Like if you're going to be making like an online gaming thing, like what's the better way of doing it? Is you're asking, Dermer? Yeah, so if you're going to be doing that, don't use srand and don't use rand. Both of these are terrible algorithms. So the reason why I teach these is because they're simple enough for people in their third week of programming to learn. That's why I teach them. There are better replacements for them that, for who knows what reason, the standards committee made impossible for people to memorize. Impossible for people to memorize. If you want to generate a number from 1 to 10 using modern C++, people have to Google it like every time. So there is a replacement random library number generator named random. And let's try this. And it's going to like C. Okay. Let's see here. We're going to need uniform hit distribution. Okay. So this is the code to generate a random number from 1 to 6 using modern C++. So you include random. You make a random device. You make a std://mt19937 because that's easy to memorize right there. Every first semester student can memorize std://mtt19937. It's like it sounds like you're talking about a Star Trek vessel or something. Gen passing in RD, passing in parentheses, and then you do a uniform int distribution, open close bracket distrib 1 to 6. And then you pass the gen to the distrib. And that makes you a number from 1 to 6. Technically, it's superior. Mentally and pedagogically speaking, this is a disaster. So I don't teach it to first semester students. Sure, technically it's good, but from like a teaching perspective, they completely screwed up. There is a proposal right now to just make it easy to get a random number. And if that happens, I'll teach it. But until then, I just do this instead. And this is the old bad way. All right. So does that answer your question, Dermer? So basically, there is a better way. It's in the random header file. You can look into that. There's sample source code like that that shows you how to roll dice actually more securely and randomly. But the old way, like you could actually memorize. What about a competitive multiplayer game where the student random is players to random numbers instead of match? Yeah, you can do that, I guess. The players, yeah, sure. I mean, like when I generate prime numbers for crypto stuff, like I have to shake the mouse kind of randomly. Yeah, you can do that. Okay. Anyhow, so we're gonna do lab time now. So the lab time is this. You are going to make Mocking Spongebob and put a string. And one thing you might want to do is, where's the string? Yeah. One thing you do is do read line. So read line reads an entire sentence, not just a word. Yep. So please enter a sentence. And it will run through it. Okay. Read and double radar, read one word. Read line and get line, read entire sentences. Okay. So using this pattern here, what I want you to do is flip a coin and uppercase the letter if it's heads and lowercase the letter if it's tails. Begin. I'll give you, 15, 20 minutes. And screenshot it when you're done. Yep, I'm going to pause recording. And we are back. Let's do this. So, everybody post your screenshots. So, what we want to do is we want to flip a coin. And we want to say if rand modulus 2, that flips a coin. And then else. I saw some people using like else if or something like that. Don't do that. Just remember, else triggers if the first thing doesn't trigger. So you flip a coin. If the first thing triggers, you do that. If it doesn't, you do the other. Okay. So for every character in the string, we're gonna flip a coin. If we got heads, then we say the character is equal to the 2 upper version of the character. If we got tails, we can do the character equals the 2 lower version of the character, or we could switch those two. It doesn't matter at the slightest. And then we just output the character. And that's it. That's your lab time for today. So if the FAFSA says college is, if you say college is expensive, then the FAFSA says college is expensive. And if you do it again, then you'll see it capitalizes different letters every time. I was opposite with my 2 upper and rand implementation. Remember, it doesn't matter which one. I was opposite with my 2 upper and rand implementation. It doesn't matter whether you do 2 lower first or 2 upper first. It's 50-50. It's the same thing either way. I wouldn't be too concerned about it. Okay, so let's take a look at the lab code here. It looks pretty good. Herbert, remember, we needed to lowercase the uppercase version, so we needed to do this as well. Lysandra, it's looking good. Formatting, I'd probably mess with the formatting a little bit. One little Vim trick is GG equals capital G. GG equals capital G reformats your code. That's pretty important. Yeah, same thing for Romero. Your code is all kind of like left justified here, so don't. GG equals capital G, it's a lifesaver. It lets you see if you're missing a matching brace and things like that. And again, a lot of students do something like this. Like they do the open brace, and then they forget the close brace. I never forget those things, because whenever I do an if statement these days, I always start off like this. I do the open brace, I do the close brace, and then I hit Shift-O and do the meat of the sandwich instead. Yeah, you forgot the curly braces entirely. So you need curly braces here and here, and around these two as well. 2 upper, it needs to be 2 upper as well. Don't do both CN and read line at the same time. These do the same thing. So read and double right arrow are the same thing. Read line is like a standard C++ function called getLine that gets an entire sentence. So if you do this, you don't need to do that. And also, this won't work if you don't include the read library, which is here. Okay. So yeah, try compiling your code. It'll tell you if you're doing it right. If all you do is just write code and you don't ever compile it, so there's a habit that everybody needs to get into, which is to compile your code every like 2 to 3 lines, and you will know very quickly if like you screwed up, right? Like if you type string s equals read line and you don't have the matching include up here, it will tell you, I have never heard of read line in my life. So you need to get into the yeah. I wouldn't put spaces here either. And you're missing a semicolon here. You need to, is there another way to read the string without the read library? Yes, there is. If you want to do it using the standard library, it would be string s, like that. Let's just comment that. String s, and then we do getLine cn into s. Like that. And that is the standard library we're doing. My read library is better than the standard library. So, but it's functionally equivalent for what we have here. Yep. Zofka looks good. I don't know what the R is for. I don't think the R is doing anything. See that please enter sentence, get line for every character in the input. So again, this is like a for each loop. For every character in the input, we flip a coin, and then you're either outputting the 2 lower version or the 2 upper version. But remember what I said about 2 lower and 2 upper. They return an integer, not a character. So this is going to give you a bunch of ASCII codes, not actually the characters that you're expecting. And also you need to have an end line at the end of this, or it's all going to be on the same line. Okay. So that's why I did this. Whenever you use 2 upper and 2 lower, there is a special bug that you need to just be aware of, that you can't see out it directly, because if you see outed this directly, it's going to print a number to the screen, and that's the ASCII code. Can figure it out, Raphael. Okay, hopefully this makes sense to you. So your next homework assignment is called times table. So if I become curly and cd into times table, then you can see there's a README file that's quite detailed. What you're going to basically be doing is generating a times table, like you remember from like elementary school, right? So if you do a times table, times table reference. So if I say from 1 to 10, then it generates the times table from 1 to 10. 4 times 6 is 24. 10 times 6 is 60. 7 times 8 is 56, right? And so you type in the smallest number of the table, the largest number on the table, and it will generate this. We're going to do this using what's called a doubly nested for loop. So a doubly nested for loop is going to look like this. Bin main.cc. Let's just whatever. It's going to look like this. For n I equals 0, I is less than 10, I plus plus. So you can have a loop inside of a loop. Okay. If I were to see out I j, let's make this a little shorter. Let's make it like 5. Then if we kind of step through this in our heads, what's going to happen is that I is going to be equal to 0 the first time through. 0 is less than 5, so we continue on. It then creates a variable called j. It's initialized to 0. 0 is less than 5, so we continue on. And it's going to print out the value of I, 0, value of j, 0, and then we hit the bottom of the scope. So when you hit the bottom of the scope, you go back up to the top of the scope. And the matching scope, this brace matches this one. So we add 1 to j, and we do it again. So we're going to output 0 and 1. And then we do it again, 0 and 2, 0 and 3, 0 and 4. Then when we go up to the top here, j is going to be 5. 5 is not less than 5. We get to the bottom of the scope. And then we hit this curly brace. So we come back up to here. We do the I plus plus. I is now 1. Then it's going to output 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Then we get to the bottom of this and come back up here. Now I is 2. It's going to do 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. Okay. So I don't want to spoil this too much for you, but this is pretty close to what you need to do for the times table assignment. Maybe you could do something like this. You might notice the formatting used tabs. So if you want to do a tab, it's \T, like that. And so something like this is pretty close to what you need to do for your homework assignment. So look at that. Got maybe an off by 1 error. Maybe there's some other stuff. I don't want to make it too easy for you, but this is actually pretty close to what you're going to need to do for the homework assignment. About half of it is figuring out how to do a doubly nested for loop like this. We're going to practice it more on Monday. The other half is vetting the input. So there's actually a lot of ways that the thing could be bad. For example, if the smallest number on the table is 10 and the biggest number is 2, that's bad, right? Because the smallest number is bigger than the biggest number. So there's a lot of things like that you have to think about. Or if the smallest number is squirrel, right? So there's actually like probably half the points on this assignment is just from vetting the input, right? So the, which, do you want to do an addition table or a times table? I want to do squirrel, I want to do the Declaration of Independence, right? Which a lot of you had fun with on the previous assignment. The Declaration of Independence, when you were expecting a number, doesn't work. So make sure that you vet your input thoroughly. That's probably half the points, and the rest of it is doing something very, very close to what we have on the screen here. That's probably going to be something along the lines of the minimum number. That's probably something along the lines of the maximum number. Again, I don't want to reveal it for you. There is, like if we do 1 to 10, there is like an X here if you're doing a times table. There is a plus here if you're doing the addition table. So 4 plus 6 is 10. So there's a little bit of stuff you have to do, but like, I don't want to give you too much. It's due next Friday at the start of class. But it's going to be something along these lines here. Okay, this is a pretty good starting point for that assignment. Your books are due on Wednesday, and so then we're just going to leave it here, and we will continue messing around with doubly nested for loops on Monday. But I would try and see how much of this you can get done. In the meantime, read the README file. It's got a discussion of all the different kinds of errors that can come up. There's a maximum size of 20, I think. So, read the README carefully. I would start coding it now. There was a lot of people online last night at 11:30 at night. Min Corelli, of course, is a hero. He was helping like 15 different students at like midnight the night before it's due. I've said this many times, don't wait until the night before it's due to work on the assignment. You always want to have like a 24-hour cushion so that if things go wrong and you don't know how to like check to see if somebody typed in the Declaration of Independence when you thought it should be a number, that you've got that cushion to find any last minute bugs and things like that. I had a lot of students starting yesterday night, and that's just, like I said, that's the only way you can fail this class. The only way you can fail this class is if you don't do the Zybooks, so you don't learn the material really well. And if you like wait to the last minute to do the homework, because you will be surprised in a bad way by most of the homework assignments. And you need to have enough time that if you get stuck, you can get unstuck. Okay. So yeah, Min Corelli was absolutely fantastic. He brought in cookies to the class today. I brought in cookies to the class, and unfortunately, you guys are online. You get virtual cookies. Here you go. I'll put a meme on the chat channel. You get virtual cookies. There you go. You get a Cookie Monster on Discord. But yeah, he was a real champion. I was playing video games. Like I had the Discord open, and I was like kind of helping some students asking questions. But he was like on video, and he's like showing things, and he's answering questions for like 15 different people. He's not being paid for any of it, right? So I kind of felt a little bad about it, but I'm falling behind in Path of Exile, so yeah, I wasn't gonna do it. I was just answering a few questions here and there. So yeah, the cookies were good. And I'm going to have some extras if you're going to like the board game night, which starts tonight. Tonight is game night though. Board game night. Yeah. On campus. There's a board game club on campus. AC2 something. I can tell you if any of you guys are into board games, I can tell you where the thing is. I'm going to stop the recording here, but I'll tell you about the board game night in a second.